Hello, ladies and gentlemen. So now we have this sheet, and it's going to talk to us about powers with integer exponents. And we've actually talked about this already. These are your negative exponents. This is just a formal sheet that we can go over and maybe remind ourselves of what's going on. So we talked about this idea that if I have a negative exponent, that I like to think about it as if it's negative in the top, and you got to create that top in this situation. So you put it over top of 1. If it's negative in the top, then it will become positive in the bottom. And the opposite is true too. So if it's negative in the bottom, it's going to be positive in the top. So an integer base raised to a negative exponent is equal to the reciprocal of the base raised to the corresponding positive exponent. That's really complex wording to say what I said. If it's negative in the top, it's positive in the bottom. So this is what it's saying. There's an integer base, 4, it's an integer, raised to a negative exponent, is equal to the reciprocal. The reciprocal of 4 is 1 over 4 to the same positive exponent, which is 4 to the 1. And we wouldn't even write that. We'd write it as 1 over 4. So negative 6 is going to be equal to the reciprocal of negative 6, which is 1 over negative 6 to the positive exponent. And that's what that would be in that case. Notice the negative 6 stayed negative. It's just the 3, the exponent 3 changed. And here's another way of thinking about it. So if I had a over b both to the negative m, let's think about that negative m. That m goes to top and bottom. We've talked about why that happens with easier questions. And so I've got a negative on the top, I've got a negative in the bottom, and so put both where they're going to be positive. So there's the one on the positive, and there's the other one positive. So they reverse sides. Another way to think about it, though, is to look at the base first of all, and to flip the base. That's the reciprocal. So what they're saying is, so here's my a over b. The reciprocal of a over b is b over a, and it has the positive of the exponent. And so that's just another way to do it. So here's an example. If I had 3 over 5, the reciprocal of 3 over 5 is 5 over 3 to the positive exponent. That's probably a silly one to do. Let's do a more interesting one. 2 over 5 to the negative 3. That's a better one. We could flip the base and have the positive exponent. So see what happened there? That negative got taken up by flipping the base, in which case it would be 5 to the 3 over 2 to the 3, and you could finish that off and get numbers if you wanted. So it's 125 over, oh no, it's not 5 times, yeah, it is over 8 if you really wanted to. Another way to look at this exact same problem, 2 over 5 to the negative 3, is you take that negative 3 to the top and the bottom. So it's 2 to the negative 3 over 5 to the negative 3. Well, put them where they're going to be positive. So 5, that's a negative 3, by the way. So it's going to be 5 to the positive 3 over 2 to the positive 3, which is 125 over 8 again. And again, both work, and it doesn't matter which one you do. 0 exponents, we talked about that. Anything to the exponent 0 is 0. So this, 0 exponents, we talked about that. Anything to the exponent 0 is 1. So 8 to the 0 is 1. But then again, so is this. I don't care. It has an exponent 0. It's 1. That's just the way it is. So let's flip that page over. Let's see what we got. We got some examples here. Represent each of the following as a power with a negative exponent. Okay, so they want the negative exponent, but they also want us to use the smallest possible integer base. So 1 over 25 certainly could be written as 25 to the negative 1. Okay, so it has an exponent of 1. I bring it up to the top, and it's 25 to the negative 1. But it's not really the smallest positive base, because 25 is actually 5 squared. So 25 could be 5 squared. So this could be written as 5 to the negative 2. That would be with the smallest base that we could have. 25 is larger than 5. So again, this one, I guess if I'm looking at this, I would say this would be 1 over 10 to the 3. And if I wanted to write it with a negative exponent, it would be 10 to the negative 3. So use the exponent rules to simplify each of the following. At each step of your solution, keep the expression in power form. So I've got 5 to the 3 times 5 to the 4. So the rule is I'm supposed to do 3 plus negative 4. So I guess the answer is going to be 5 to the negative 1. And if we wanted to keep it with a positive exponent, it would be 1 over 5. Another way to do the exact same question is to look at these two and realize that this is 5 to the 3 times 1 over 5 to the 4. In which case it's top times top, bottom times bottom, 5 to the 3 over 5 to the 4. Where are there more 5s on the bottom? How many more? 1. And again, it's just a different way of doing the exact same question. That's how I'm going to look at this one. Where are there more 3s on the bottom? How many more? 3 of them. So it's 1 over 3 to the 3. Or 3 to the negative 3. Both of those mean the same thing. 2 to the 5 to the 0. Well, it just doesn't matter, people. I don't need to do 2 to the 5 because as soon as it goes to the 0, it's going to be 1. 4 to the negative 2 times 4 to the 5. Let's deal with the top first. So it's going to be 4 to the 3 on the top over 4 to the 6. Where are there more 4s on the bottom? How many more? 3 more. So if we wanted to have a negative exponent, we could have 4 to the negative 3. Now example 3, you gotta be on your game here. This is addition. This is not multiplication. So the exponent laws do not apply. Don't apply. So the best I can do is do 2 to the 3, which is 8. And the best I can do is 1 over 2 to the 4, which is a decimal. So then this is going to be 8 plus 1 over 16. 16 is a decimal, so 1 divided by 16 plus 8, 8.0625. It told me to evaluate, and it told me to simplify. So I simplified and I evaluated. Notice again, this is negative, so the exponent laws do not apply, even though they have the same bases. There's not multiplying, it's not dividing, so I don't use the exponent law. So the best I can do is calculate this one, and then subtract them. So 3 to the 0 is 1. 3 to the negative 2 is going to be 1 over 3 squared, which is going to be 1 minus 1 over 9. Well, I think 1 over 9 is 0.11111. It is. So subtract that and add 1 to it, and I get 0.88888888. So it's approximately 0.9. Approximately. All right, that was fun. This one. The bases are the same. So I can, and the rule is I'm supposed to add the exponents. That's got a little invisible 1 there. So it's going to be negative 2 to the negative 3, which is going to be 1 over negative 2 to the 3, which is going to be negative 2 times negative 2 times negative 2, which is negative 8, which is negative 1 over 8. That's a great question. I like that one. And this one, let's see what we got going on here. I got a negative and a 2 over 3. Well, first of all, I would make this look a little nicer. I would put the negative with the 2 and then deal with the exponents. So that would be the first thing. That negative there, I'd put with the 2 and leave it in the top. I think what I would like to do next to make my life easy is put these two together. So it's going to be negative 2 over 6, over 3 to the 12. And then it's simply going to be negative 2 to the 12 over 3 to the 12. And it did say evaluate, so I guess I better look at that. I'm going to do it from here, though. I'm going to be smart. I'm not going to do it from here. So I'm going to do 2 negative divided by 3 equals, so it's 0.666666 to the exponent 12, and I'm going to get an answer of, now, so this is scientific notation. I know how to do scientific notation, so we're going to move this 3 over, so it's 0.0077 approximately. And let's see if that's right. Moved over once, moved over twice, moved over 3 times. It is right. Or change the mode of your calculator. And there we go. Okay, so that finishes that page. That takes you to a exponents progress check. Let's do this up and let's submit this. I'll give a Dropbox for this, so it's this page and this page, but the group in school that was in class today said that they wanted to do it and submit it for some marks, and I thought, hey, why not? We'll go for that. This is an old course code. I had pulled this from an old workbook, so we'll just get rid of that. That's an old course code. Same material, different code, and there you go. We'll come back with one more video to finish off today's work, and that'll be with rational exponents, and then you'll have some textbook work to do. Remember, you got a test on this coming up on Friday. Okay. Oh, Friday if you are one of the cohorts, and Tuesday if you're the other cohort.